21 medical discoveries that changed the world. Throughout history, scientific discoveries have saved millions of lives. These breakthroughs didn't just improve medicine, they fundamentally changed our understanding of life, death, and the human body forever. Facts 1 to 5:1. The accidental miracle, the discovery of antibiotics. In 1928, Alexander Fleming returned to his cluttered lab to find that a mold called Penicillium notatum had contaminated one of his petri dishes. Crucially, he noticed that the bacteria around the mold were dying. This accidental observation led to the creation of penicillin, the world's first true wonder drug. Before this, a simple scratch from a rose thorn or a bout of strep throat could be fatal. Antibiotics work by targeting the specific biological structures of bacteria, such as their cell walls, without harming human cells. This discovery turned once lethal infections into minor inconveniences and laid the groundwork for all modern pharmacy, effectively adding decades to the average human lifespan. 2. The shield of humanity. Development of vaccines. Before vaccines, diseases like smallpox and polio ravaged entire civilizations. In 1796, Edward Jenner observed that milkmaids who contracted cowpox seemed immune to the much deadlier smallpox. He theorized that exposure to a weaker version of a disease could train the body's immune system. This led to the birth of immunology. Vaccines work by introducing a harmless piece of a pathogen, an antigen, to the body, allowing the immune system to build a library of memory cells and antibodies. This discovery represents the only time in history that humans have completely eradicated a disease, smallpox, through global cooperation, transforming medicine from a reactive practice into a proactive, preventative shield. 3. The end of agony. Anesthesia for surgery. For most of human history, surgery was a terrifying last resort, performed while patients were conscious and screaming, held down by strong men. The discovery of effective anesthesia in the mid-19th century, starting with ether and chloroform, changed everything. Anesthesia works by temporarily interrupting the nervous system's ability to transmit pain signals to the brain, or by inducing a controlled state of unconsciousness. This didn't just save patients from trauma. It gave surgeons the time and precision needed to perform complex internal operations that were previously impossible. Every modern procedure, from a simple dental filling to a complex heart transplant, rests on this fundamental ability to switch off pain. 4. Seeing the invisible. X-ray imaging technology. In 1895, Wilhelm Röntgen was experimenting with vacuum tubes when he noticed a mysterious glow on a nearby screen. He soon discovered that these X-rays could pass through human flesh but not dense bone, capturing the first internal image of a living person, his wife's hand. This was the birth of diagnostic imaging. For the first time, doctors could see fractures, tumors, and foreign objects without cutting a patient open. This discovery stripped away the guesswork of medicine, allowing for accurate diagnoses and targeted treatments. It paved the way for the entire field of radiology, changing the hospital from a place of external observation to a center of internal transparency. 5. The magnetic portrait, MRI scanning. While X-rays are perfect for bone, the invention of magnetic resonance imaging, MRI, in the 1970s allowed us to see soft tissues, the brain, muscles, and organs, in exquisite detail. Unlike X-rays, MRI uses no radiation. Instead, it uses powerful magnets to align the protons in the water molecules of your body. When radio waves are pulsed through, these protons emit signals that a computer translates into a 3D map. This discovery revolutionized neurology and oncology, allowing doctors to detect strokes, multiple sclerosis, and tiny tumors with near-perfect accuracy. It is perhaps the most complex application of physics in the history of medicine, providing a non-invasive window into the very machinery of life. Here is the second part of medical history, facts 6 through 15. Each fact has been expanded to approximately 900 characters, focusing on the scientific mechanism and the profound impact on human civilization. Facts 6 to 15. 6. The gift of life, blood transfusions. For centuries, blood was seen as a mystical essence, but early attempts to transfer it often resulted in instant death. The game changed in 1901 when Carl Landsteiner discovered human blood groups A, B, and O. This discovery revealed that our immune systems carry antibodies that attack foreign red blood cells, causing lethal clotting. By matching donor and recipient types, doctors turned blood into a life-saving resource. Further developments in anticoagulants allowed blood to be stored in banks for the first time. This breakthrough is the silent foundation of all modern trauma care and complex surgery. It allows the body to survive massive blood loss during childbirth, accidents, or operations, turning what used to be a fatal, empty tank into a refillable system that sustains life through crisis. 7. Regulating the engine, insulin for diabetes. Before 1921, a diagnosis of type 1 diabetes was a slow, agonizing death sentence, as patients literally wasted away because they couldn't process sugar. Frederick Banting and Charles Best changed history by isolating insulin from the pancreas. They discovered that this hormone acts as a key that unlocks cell membranes, allowing glucose to enter and be used for energy. When they successfully treated 14-year-old Leonard Thompson, they transformed a terminal metabolic collapse into a manageable condition. This discovery was one of the fastest Nobel Prize winners in history, and it remains a miracle of endocrinology. Today, millions of people live full, healthy lives because we learned how to manually regulate the body's primary energy balance through the calculated administration of this vital hormone. 8. The ultimate repair, organ transplantation. The dream of replacing a failing organ with a healthy one was long considered science fiction until the first successful kidney transplant in 1954. The core challenge was not just the surgery, but rejection, the immune system's tendency to attack the new organ as a foreign invader. The discovery of immunosuppressant drugs allowed doctors to silence this defensive response just enough for the body to accept the graft. This breakthrough turned the end-stage failure of the heart, liver, or kidneys from a terminal event into a chance at a new life. It redefined the boundaries of human biology, proving that our individual parts are interchangeable. It represents the pinnacle of surgical skill and immunological understanding, offering a second chance to those whose vital systems have completely surrendered. Shutterstock 9. The invisible enemy, germ theory of disease. Until the mid-19th century, people believed diseases were caused by miasma, or bad air. Louis Pasteur and Robert Koch revolutionized the world by proving that microscopic organisms, bacteria and viruses, were the true culprits. By demonstrating that invisible germs cause fermentation and illness, they provided the roadmap for modern medicine. This theory led directly to the development of vaccines, antibiotics, and public health standards. It shifted the focus of medicine from observing symptoms to identifying and killing the specific pathogen responsible. The germ theory is arguably the most important conceptual leap in human history. It allowed us to clean our water, preserve our food, and understand that our greatest enemies are not ghosts or bad smells, but tiny living entities that we can see, study, and defeat. 10. The sterile sanctuary. Sterilization in hospitals. In the 1860s, a patient was more likely to die from an infection caught inside the hospital than from the surgery itself. Joseph Lister, inspired by Pasteur's germ theory, realized that surgeons were inadvertently carrying death on their unwashed hands and dirty tools. He introduced the use of carbolic acid to clean instruments and wounds, drastically dropping the mortality rate. This was the birth of antiseptic surgery. This practice evolved into the modern sterile field, where everything from the air to the surgeon's mask is meticulously managed to exclude microbes. This discovery transformed hospitals from houses of death into safe havens of healing. It made invasive surgery a viable option for the masses, ensuring that the cure was no longer more dangerous than the disease. 11. The blueprint of life, DNA structure discovery. In 1953, James Watson and Francis Crick, with the crucial data of Rosalind Franklin, revealed the double helix structure of DNA. This wasn't just a chemistry lesson, it was the discovery of the source code of all living things. By understanding how genetic information is stored and replicated through base pairs, scientists unlocked the ability to read the human instruction manual. This discovery birthed the field of molecular biology, leading to everything from forensic DNA testing to the mapping of the human genome. It allowed us to understand why we inherit certain diseases and how life builds itself from a single cell. Every modern genetic therapy and biotechnological advancement traces its lineage back to this elegant, twisting ladder that holds the secrets of our biological identity. 12. The 3D perspective, CT scans. While traditional X-rays provided a flat, overlapping view, the invention of computed tomography, CT, in 1972 by Godfrey Hounsfield allowed us to see the body in slices. By rotating an X-ray source around the patient and using a computer to combine thousands of images, doctors could suddenly see 3D cross-sections of organs and bones. This breakthrough was a massive leap for emergency medicine. It allowed for the instant detection of internal bleeding, brain strokes, and complex fractures that were invisible on standard films. The CT scan turned the human body into a transparent, digital map, providing a level of diagnostic speed and clarity that has saved countless lives in trauma bays across the world. It bridged the gap between basic imaging and the complex, high-definition digital diagnostics of today. 13. The heart's metronome, pacemakers. The human heart relies on a tiny internal electrical circuit to beat rhythmically. But when this circuit fails, the heart can stop. The development of the implantable pacemaker in the late 1950s allowed us to externalize this vital function. These devices use timed electrical pulses to force the heart muscle to contract, maintaining a steady pulse. This discovery turned fatal heart blockages and arrhythmias into manageable chronic conditions. It was one of the first times we successfully integrated electronics with living tissue to replace a failing biological function. Today, these tiny, long-lasting computers sit silently in the chests of millions, acting as a permanent, artificial guardian of the heart's most basic rhythm, ensuring that the engine of life never misses a beat. 14. The chemical crusade, chemotherapy for cancer. The realization that certain chemicals could selectively kill fast-growing cancer cells began in the 1940s, surprisingly derived from research into nitrogen mustard gas. This birthed the era of chemotherapy. Unlike surgery, which removes a localized tumor, chemotherapy is a systemic search-and-destroy mission that travels through the blood to find cancer cells wherever they hide. By targeting the cell division process, these drugs can shrink tumors and put even advanced cancers into remission. While the treatment is famously harsh on the body, it represents our first major victory in the chemical war against the emperor of all maladies. It transformed many forms of cancer from certain death sentences into treatable and sometimes curable diseases, sparking decades of research into targeted, less toxic oncological therapies. 15. Restoring mobility, artificial joints. For most of history, a worn-out hip or knee meant a life of immobility and chronic pain. The development of modern joint replacement surgery, particularly by Sir John Charnley in the 1960s, changed the aging process forever. By using high-density plastics and specialized metal alloys, surgeons learned how to replace a degraded joint with a mechanical version that could last decades. This wasn't just a mechanical fix, it was a restoration of human dignity and independence. Joint replacement is now one of the most common and successful surgeries in the world, allowing the elderly to remain active and pain-free. It proves that when our biological bearings wear out, we can use engineering to rebuild the human frame, extending the functional lifespan of our bodies to match our increasing longevity. 16. The minimalist revolution, laparoscopic surgery. For over a century, surgery was synonymous with large, traumatic incisions that required weeks of painful recovery and left massive scars. The advent of laparoscopic or keyhole surgery in the late 20th century fundamentally altered the surgical landscape. By utilizing a laparoscope, a thin tube equipped with a high-definition camera and a light source, surgeons can now see inside the body through an incision no larger than a buttonhole. Specialized, long-handled instruments allow for the removal of gallbladders, the repair of hernias, and even complex organ resections with extreme precision. The biological benefit is immense. Because the internal organs are not exposed to the open air and the abdominal wall remains largely intact, the body's inflammatory response is significantly reduced. Patients who once would have spent a week in the hospital now return home within 24 hours, experiencing less pain, a lower risk of infection, and a dramatically faster return to their daily lives. This discovery represents the transition of surgery from a blunt, invasive force into a refined, high-tech art form, paving the way for the robotic-assisted surgeries of today that can operate with sub-millimeter accuracy. 17. The arms race. Antibiotic resistance research. While the discovery of antibiotics was a miracle, the subsequent research into antibiotic resistance has become the defining challenge of modern global health. Almost as soon as penicillin was introduced, bacteria began to evolve defenses, a process driven by the ruthless logic of natural selection. Scientists discovered that bacteria can share resistance genes through horizontal gene transfer, effectively teaching each other how to survive our strongest drugs. Research in this field has revealed the terrifying reality of superbugs like MRSA and VRSA, which are immune to traditional treatments. This discovery has forced a complete shift in how we view medicine. It is no longer a static victory, but an ongoing high-stakes arms race. We have learned that overusing antibiotics in agriculture and for viral infections accelerates this resistance. Today, this field is pioneering phage therapy, using viruses that eat bacteria, and the development of decoy molecules that disable bacterial defenses. This research is the thin line standing between us and a post-antibiotic era, where a simple infected scratch could once again become a fatal event, reminding us that medicine must be as adaptive as the life forms it seeks to control. 18. The predictive mirror. Genetic testing. Genetic testing has transformed the human genome from a mysterious biological script into a readable, predictive map. With the completion of the Human Genome Project, we gained the ability to scan an individual's DNA for specific mutations that indicate a predisposition to diseases like breast cancer, BRCA genes, Alzheimer's, or cystic fibrosis. This discovery shifted the entire philosophy of medicine from reactive to predictive. For the first time, a person can know their medical future before a single symptom appears, allowing for aggressive, preventative measures or personalized screening schedules. Beyond disease risk, pharmacogenomics, a subset of genetic testing, allows doctors to determine exactly how a patient's unique genetic makeup will react to a specific drug, eliminating the dangerous trial and error phase of prescribing medication. We have moved from a one-size-fits-all approach to precision medicine, where treatments are tailored to the patient's specific molecular identity. This is the ultimate empowerment of the patient, turning the invisible code of our ancestors into actionable intelligence that can stop a disease before it even begins to manifest. 19. The fountain of repair. Stem cell research. Stem cell research represents the holy grail of regenerative medicine, the ability to regrow or repair damaged tissues that were previously considered permanently lost. Stem cells are the body's master cells, possessing the unique ability to transform into any type of specialized cell, from a neuron in the brain to a muscle cell in the heart. The discovery of induced pluripotent stem cells, iPSCs, allowed scientists to turn ordinary adult skin cells back into these master cells, bypassing the ethical dilemmas of the past. This breakthrough has opened the door to treating devastating conditions like Parkinson's disease, spinal cord injuries, and type 1 diabetes by replacing destroyed cells with fresh, functional ones grown in a lab. We are now on the verge of bioprinting entire organs using a patient's own stem cells, which would eliminate the need for organ donors and the risk of rejection. This field is fundamentally changing our understanding of aging and injury. It suggests that the human body is not a machine that must inevitably wear out, but a biological system that can, with the right cellular instructions, rebuild and renew itself from within. 20. The molecular speedster. mRNA vaccine technology. The development and global deployment of mRNA vaccines marked a historic turning point in biotechnology, representing a paradigm shift in how we protect the human species from viral threats. Traditional vaccines often rely on growing weakened versions of a virus in chicken eggs, a process that takes months. mRNA technology, however, uses a piece of genetic code to give your cells instructions on how to build a harmless piece of the virus, the spike protein, themselves. Your immune system then sees this protein, recognizes it as an invader, and builds a massive army of antibodies. This discovery allowed for the creation of a life-saving vaccine in record-breaking time during the COVID-19 pandemic. But the impact goes far beyond one virus. mRNA is essentially a programmable medicine. Scientists are now using the same platform to develop cancer vaccines that teach the immune system to recognize and destroy specific tumors, as well as vaccines for malaria and HIV. It has turned the human body into its own high-speed pharmaceutical factory, providing a flexible, digital, and rapid response weapon that can be updated as quickly as a virus can mutate. 21. Medicine without borders. Telemedicine technology. Telemedicine is the digital bridge that has finally broken the physical barriers of the doctor-patient relationship. While the concept has existed for decades, the integration of high-speed internet, wearable health sensors, and artificial intelligence has turned it into a global revolution. It is not just about video calls. It is about the Internet of Medical Things, IOMT. Patients in remote villages can now have their heart rhythms monitored in real time by specialists thousands of miles away using smartphone-connected EKGs. AI algorithms can now analyze skin lesions or retinal scans through a simple photo, often with higher accuracy than a human generalist. This technology has democratized healthcare, bringing world-class expertise to underserved populations and reducing the burden on physical hospitals. It allows for continuous care rather than episodic care, where chronic conditions are managed through constant data flow rather than once-a-year checkups. Telemedicine is the final frontier of medical discovery, proving that in the 21st century, the most powerful tool in a doctor's bag is no longer just the stethoscope, but the ability to deliver life-saving information across any distance instantly.